Hey everybody, how's it going? I don't know who watched my weekend competition, but I got 3 out of the 4 questions right, and the 4th one I would have been able to do if I knew what I'm hopefully about to try to figure out, which is if you take a string of characters and then you consider every possible arrangement of the letters in that, then, well, first off, how many different combinations are there? And then secondly, excuse me, how do we find the ith, iteration? So like 0 would be the lowest, what do we call that? Like ordering. There's a specific word that I'm looking for. I can't. So let's go here and see if we can find the actual problem in question. Count good triplets. Should I do that? Should I do that before? I'm here. I'm here anyway. I'm getting sidetracked. Whatever. I've done this before. Given an array of integers and 3 integers ABC, you need to find a number of good triplets. A triplet is good if the following conditions are true, where x denotes the absolute value of x. Return the number of good triplets. Okay, it's an easy problem. Well, we'll just knock it out. For I in range, length ARR. What? It doesn't. Oh yeah. So I plus 1, j plus 1. I hate these. I hate these problems that are just like busy work. It just. It's like, what are you actually doing? Just figuring out a bunch of stupid rules. Whatever. Okay. Not try to do anything fancy, like make it a one-liner or anything. Just CNT plus equals 1, CNT equals 0. Okay. Get this out of the way and then I don't need to worry about it. Slocky the E. Alright, cool. Hey, I thought my streak was long. But doesn't matter. I'm not focusing on that. Okay, so let's get back to our list of questions here. Okay, so we're going to have, it was a hard problem, and I believe it is the most recent one, smallest palindromic rearrangement, number 2. So this, oh, look, it saved my crap that I typed. Okay. You're given, that surprises me because I thought that they treated just regular questions different than weekly questions. So it would make sense that they wouldn't, I guess. You're given a palindromic string S and an integer K. Return the kth lexicographically smallest palindromic permutation of S. This is the lexicographically smallest, that's the word that I was trying to think of. If there are fewer than k distinct palindromic permutations, return an empty string. Different rearrangements that yield the same palindromic string are considered identical and are counted once. I think that's assumed, but all right, okay. So this problem is a superset of the other problem that I said. It's just, if you can take a string of letters, find the kth lexicographically smallest not palindromic, just permutation of S. And then you can construct a palindrome out of that by simply mirroring the first little bit on the end. Or if you have an odd number of characters, then you will have one extra one in the middle, but it has no effect on the lexicograph or on the permutation, because it's fully dependent on the earlier letters, which are more important for this. Oh man, there's some chemical in the air again. Hold on, let me put an eye drop in. Okay. Can't be helped. Okay. So, let's see here. So, now the idea that I had... Here, let me get a notebook open here. New Python. Okay. So let's say that you have some string A, B, B, C, C, D, D, whatever. Now, I think that you can define a permutation recursively. You can say that the most significant digit is A. So whatever the placement of that is the most important. In numerical terms, you could say that this is strictly it's almost like a bigger digit, almost. So, you know, if you have a number like 9,000, for example, here, let me put in some random digits in here. And then if you change the first digit, then that is going to change everything, and it's not going to. If you change this to like 8, and then you change the rest to 999, it doesn't matter. It's never going to catch back up to the most important change. And then the last one would be. Is this right? Am I right? Suddenly I'm not even sure that I'm right. Oh no. I think I might be wrong. Interesting. Well. I think my entire idea was wrong. Oh yeah, I had no chance of getting this in the competition. Maybe we could just start by looking at the most significant digit. Well, let's start at the least significant digit. But you know what? Let's try to look it up. I don't know. I don't know how to do this. So I just realized as I was typing that my entire idea was wrong. So this is humiliating. Okay. Lexigraphically enumerated permutations of a string. Permutations of a given string. I mean, you could brute force it if the range were smaller, but what is that? 10,000. Can't do it for 10,000. Your task is to return all permutations of a given string in lexigraphically sorted order. Aha! This sounds exactly like what I'm doing. Okay. Yeah, but you see, look, this is just brute forcing every single one of them. This is not going to work. Okay. Not going to work. Well, let's see if ChatGPT knows how to do it. Let's say I had a large string of up to 10,000 characters, and I wanted to know the ith lexicographical lexicographical ordered permutation of the string. For example, the 0th permutation would be all the what am I trying to say? Would be all the. Here, let's switch this to 03. For example, the 0th permutation would be all of the letters sorted, and the last permutation would be all the letters sorted in reverse order. Okay. Okay, now I believe that I was right about the number of permutations, but not the ordering. So the number of permutations should be equal to a recursive n choose k, where k is the number of letters, is the number of the current letter, and n is the number of letters greater than or equal to the current, and all those are multiplied together. To make it easier, okay, I think that this limitation is necessary because the number of combinations that there could possibly be is just absolutely insane. To make it easier, the highest ith permutation that will be requested is 1,000,000. Okay, let's see what it says. I believe that ChatGPT did pass this question during the round, so it should know how to do this simple subset. Okay, goal is to find the lexicographically ordered permutation where the 0th permutation is sorted strings. Do you need to use a recursive n choose k approach? Well, let's see what it says. I hope I didn't mislead it. Yeah, well, if it gets confused, then I guess ChatGPT be dumb. It could be a lot of duplicate characters. You see, it's thinking. It's thinking. Maybe I did mislead it, and maybe it will correct itself. Oh, it's been thinking for a while. Okay. Okay, returns the ith lexicographically ordered permutation for a multi-set of string that may have duplicate characters. This approach worked by fixing one character at a time. For each candidate letter, we compute how many permutations. See, in my mind, you could place the first characters, the lowest characters, and then the second lowest characters, and then the third lowest characters. I think I definitely had a way to generate all of the permutations, but it wouldn't have been sorted the way that I was envisioning. So, multi-set permutations. Okay, 0th permutation, 3rd permutation. So let's see what this does here. All right, given a frequent dictionary multi-set frequency of letters, compute the total number of distinct permutations. Total exponential divided by C1 exponential, C2 exponential, Cn. To avoid computing astronomical numbers, if the count exceeds the cap, return the cap, or any number greater than or equal to signal at least this many. Okay, that works. Okay, so math.com. Okay, this could be useful. Go back. Go away. Go away. Explain math.com. Okay, returns the binomial coefficient. All right, this represents the number of, why is it going so slow? The number of ways to choose k items from a set of, so combinatrix, this is just the n choose k thing. So, cool. I did not know that that existed. That's actually kind of awesome. Okay, so to a certain extent, I was right about the n choose k part, I think. Let's see if this actually works. All right, 0th permutation is AABB. I would like to see what it does. So for I in range 100, I assume it will probably break. But let's see what it does. All right, out of range. Maximum index is 5. So AABB, and then what does it do? ABAB, so it starts pushing the A to the right. ABBA, BAAB. Okay, and for two of them that makes sense. But what happens when there's more numbers? So sorted, and then okay, so it starts pushing the smallest one to the right. Interesting. Okay, and then it pushes the smallest one further to the right and the furthest, and then it pushes the next one. Okay. Okay, I've got to figure out how this works, or else I'm just going to keep failing. Given a frequency, multi-set frequency of letters, to avoid computing astronomical numbers, combinatrix. Okay, kth lexicographic permutation. This is exactly what I want. So frequency equals counter. This is where I started. Keys equals sorted frequency. All right, a total number of distinct permutations capped at 1e to the 6th if huge. Total permutations, let's see how fast it is. I just put in a bunch of letters here. I assume that there are, Well, does it matter? I mean, a string is a string. Oh, no. Let's go all the way to 1,000,000. Okay. Yeah, it seems like it is instantaneous. 99 permutation. Oh. Well, whatever. I typed the wrong thing. Okay, so with this code, we should be able to do this problem. But first, I want to find out how the code works. So k is greater than or equal to total permutations, out of range. Okay, I don't think we need this. This will store the characters of the resulting permutation for each position in the output string, while sum of frequency.values is greater than 0. Iterate over possible characters in lexicographic order. For letter and keys, if frequency of letter equals 0, then skip letters that have been used up. Excuse me. Choose letter by increasing its frequency as if we fixed it here. Multi-set permutations. If k is lesser than count, then result. Otherwise, skip all permutations starting with this letter. It is recursive, but I had the grouping wrong. Okay. Well, now hold on. This isn't recursive. This is iterative. Skip all permutations starting with this letter. K minus equals count. What is K? This should never happen if K is in a valid range. We don't need that. Okay, if K is less than count, restore since we are not using. Oh, this is backtracking. Interesting. Frequency of letter plus equals 1, k minus equals count. I mean, that would make sense if we were adding to k, but are we adding to k? Whereas k is just something we pass in, right? So it's decrementing multi-set permutations count. Frequency. Given a frequency. I wonder if I'm just not smart enough to understand this. No, I'm smart enough. Let's figure it out. Okay, I understand this. Go away. Result equals 1. Well, yeah, of course. So this is literally just figuring out the binomial coefficient and choose k. Total minus equals count. Oh, okay. No, that's exactly what I was describing. I was starting from the bottom instead of the top, but it's the same thing. It's the same thing. So we completely agree on the number of combinations. It's just we disagreed on the ordering. So I was half right. All right. If result is greater than cap, then return cap. Because it just doesn't matter. Okay. Now, where do we call this? Multi-set permutations. Okay, so we take away the letter and then we pass the count. Actually, you know what? That makes perfect sense. That makes perfect sense because you start with a single letter and you either place it or you don't place it. And if you place it, then that number drops out of circulation. And the number of different strings that start with that letter are the multi-set permutations. Okay, do I understand this well enough to implement it myself? That's the question. Okay. I think I understand. Given a string S, which may have duplicate letters, return the kth lexicographically ordered permutation. Here, k equals the first sorted permutation. S is the input string up to 10,000 characters. K is the index of the desired permutation. 0 indexed. A string representing the kth lexicographical permutation of S. Okay, all of that makes sense. I do not need the explanation. The frequency of each character, obvious. Keys is... Alright. Frequency dot values. Okay. Apparently this is doing something weird here. Don't you have to say dot items? That seems like whatever. Maybe I don't know about Python. Okay. Total permutations is multi-set permutations count frequency. Total permutations. What do we use total permutations for? We don't use it for anything. What? Why is it here? Okay. All right. Okay. For each position in the output string, that makes sense. Do not indent more. That was kind of weird. Did you see that? Okay, iterate over possible characters in lexicographical order. That's sort of obvious. For letter and keys, frequency letter equals 0. Why would the frequency equal 0? Well, we are decrementing the character. So we're doing it every single time. Okay. You know what? I would rather that this be an extra step here. Do we add back? We never add back, right? We're only ever decrementing, and we're only ever decrementing something. Okay, so for used up in we'll duplicate this. See, I would rather clean it up as we're going, rather than repeatedly look at the same letter over and over again. That bothers me. So if CNT equals 0, then DEL Keys? What is keys? Keys is sorted frequency. Then DEL. I really hate this. While frequency and sum of frequency dot values is greater than 0. We don't need to do it like that. Does this still work if I do this? List object has no attribute items. Indeed not. Okay, so where are we? Keys.items. It's my code. See, I don't think that we need this. Sorted dot keys like that for a letter. Then DEL frequency of letter. Is it broken? Of course it's broken. Name keys is not defined. Keys dot items. Indeed. All right, okay. So, for letter and sorted frequency keys, if frequency of letter equals 0, then skip letters that have been used up. This is no longer needed. Choose the letter by decreasing its frequency as if we fixed it here. I don't like changing it and then undoing it. So the kth permutation begins with this letter. And we have used it up, right? In this case, we have used it up. Proceed with the next position. That is accurate. Otherwise, skip all permutations starting with this letter. K minus equals count. Okay. Now, I mean, in my mind, it doesn't seem like we should be changing K, but I see what it's doing. I would think like you would be adding up to a certain position, but you wouldn't want to keep subtracting from K, so I get it. Okay, let's say this is position, right? And then remaining equals position, like that. And then remaining. Let's see, did I break it? I did not break it. What is S? Why is it printing S? Did I do something that made it print S? Where's the S coming from? Oh, it's just carrying over from the line before. Okay, that's sort of silly. All right. Okay, I think I'm starting to get it. So, multi-set permutations count. Frequency equals counter of S. Result equals blank. remaining equals position. Well, frequency for letter counted. So we get rid of letters that we've used. Makes sense. For letter and sorted frequency keys, count equals multi-set permutation. I unhighlight that. If remaining is less than count, okay. Okay, let's first off, let's try to write this here. Tempted to just copy it. I mean, I'm literally going to type exactly the same thing. Oh well. Okay. Child permutations. Dictionary, and then, yeah, I think. I think that that's the right way to do it. So total equals sum of frequency dot values. Does that make sense? Total minus equals count. What the hell is total? What is total? Oh, total is the total number of characters. Okay, so remaining characters equals, yeah, sum of d dot values. That makes sense. Okay, and then result equals 1. Ah, because we're multiplying. Okay, so multiplier equals 1. This makes sense. Okay. Okay, for character, comma, cnt in d dot items. Sorted frequency. See, I don't think it needs to be sorted. It doesn't need to be sorted. Let's see here. I don't think it needs to be sorted. Yeah, there's no reason to sort it. Okay, but I will allow it. That is allowed to be sorted. So for c, cnt in d dot items, we will say count equals frequency of letter. We don't need that. We have it right here. I like using this combinatrix thing. So we're going to say m times equals math dot combinatrix remaining characters, comma cnt, and then remaining characters minus equals cnt, like that. Yeah. Okay. If I don't like cap. Max value. If m is greater than max value, then return max value. Otherwise, return m. Okay. feel like I should make some simple unit tests. Okay. For I in range 100, I can do this. Num keys equal. I want to make sure that I've got this right. Rand below. I don't know, 5 plus 1. Okay, possible keys equals. All right. Well, let's not go that low. Did I not? Okay. And then, yeah, so C equals counter. Then we will say for J in range num keys. And then C of PK of J equals 1 plus secrets dot run. Just don't type it again. Secrets dot rand below 6 or 5 or whatever. It doesn't matter. Let's do a few extra ones just in case we get some weird results. All right, and then we just want to know assert child permutations of C. This should be inside of here. That's a default value. That's a default value. Equals multi-set permutations count of C, comma what? Are we destructively modifying this? We are. Okay. Invalid syntax import. I hate it when it doesn't print anything. Man, that is fast. A little too fast, maybe. All right, okay. It seems like my child permutations method works. So let's comment this out. Hopefully I will be able to do this next time. So kth lexicographical permutation. Okay. It was sort of half right. Yeah, I don't think we need this. Yeah, so kth lexicographical permutation. I think that I understand what it's doing. Let's just def find ith permutation string and then ith, I guess. Okay. So C equals counter of S. Yeah, we got this. Remainder equals ith. And then we either place it or we don't, right? Yeah, so string builder equals probably should be an array. So yeah, I'll see. Now we're just duplicating the well, that's okay. Yeah, I'm figuring out if I'm learning here. So 4K in, I need to duplicate it because I can't iterate over something that I'm changing. C dot keys. Okay, if C of K equals 0, then del C of K. Okay, now we're either going to place it or we're not. Okay. Cost to not place equals child permutations of what? Well, of C. Yeah, now child permutations doesn't change it, does it? It's just this function changes things. What was I afraid of? C.copy, child permutations. This doesn't modify it. Why did I copy it? Well, whatever. I didn't need to copy it, I guess. Child permutations of C. Yeah. So, if cost, what a name, if cost to not place is greater than R, yeah, because not placing the letter would move it up too high, right? If the cost is too high, then we do place sb.append k, right? And it's placed, so we reduce it. This is dumb. If C of k equals 0, then del C of k. If cost to not place what? We're supposed to be inside of a loop here. Dumb. Yeah, look, I'm using k, and there is no k. So for k in sorted C dot keys. Cost to not place. Yeah, I'm screwing it up here. So frequency. What's that permutation? Frequency. That's for each letter, right? I guess that does make sense. Every single one of these . Okay. So we calculate this once, right? No. This calculation goes inside, and every time remaining minus equals count. Yeah, but we break. Look, we break if the letter is placed. Child permutations of C. The frequency is decreasing every time we place it, but we break, so we don't actually ever recalculate this. It really seems like this has one too many letters in the calculation. But we know this is working. Do we know this is working? We assume this is working. This seems like it has one too many letters in the calculation. Yeah, it seems like you should remove the letter first. Shouldn't we remove the letter first? All right. Shouldn't we remove the letter first? All right. Okay, cost to not place is greater than R, SB data pin. And break. Otherwise, remaining minus equals cost to not place. Okay, I mean, eventually we're going to find it. R minus equals cost to not place. And then we repeat. R is going to keep getting smaller. R is going to keep getting smaller until it's too expensive to not place it, and then we're going to be forced to place it. So, all right. So, yeah. If SB, if length of SB is less than length of S, that would never happen. Return join SB. Okay, so let's see here. Let's see if we are returning at least the same thing. Find ith permutation. Okay, we are returning the same thing. So, I'm still a little bit confused about this, but maybe I'm missing something. So, okay, let's come in here. Find ith permutation. Not. Oh, wow, I had no idea you could add breakpoints in here. Or I thought that was like a premium feature or something. Okay. Return. Cost to not place. Okay. So C equals counter, st odd lot. Sorted dot keys, v equals st. So we have to build the st. Equals counter of s. All right. So st equals find ith permutation of what? Well, of C, obviously. We don't need that. And then the ith permutation that we want is k. And we will see if this is correct or not. And even if it's not correct, find ith permutation. What are you talking? Oh. Yeah. Even if it's not correct, I feel like I understand the problem better. I could go look at a solution and make something out of it. So what in God's name? Okay, C equals 2. Did I... Interesting. Okay, so I got rid of the odd lot, but then I did, okay. 4k in c dot keys. I don't know if this matters, but whatever. C of k divided by equals 2. I believe that I can change it in place like that. Not supported between int and string. So what is this complaining about? Cost to not place is greater than R. Int string. What is R? Yeah. Oh, for hell's sake. AA, nothing. Did I divide them already? What is going on here? Print k, comma. It's kind of weird to put the number first, but it doesn't matter. I'm just trying to get some visibility into what's happening. Okay, so A is 1. So there should definitely have been an A. And there's no A. So okay, cost to not place is greater than R. No. What if the cost is never? What if the... We want the 0th permutation, right? Okay, it found that. Found that. Expected nothing. Okay, when are we supposed to return nothing? I guess that's the question. All right, let's see here. So if there's not enough combinations, child permutations, it's almost like we need to look at the value before this one. What if it didn't place it? I need visibility into what it's doing here. Okay, so I guess let's see what it's doing. One, two, 1, 1, 1, 0. Okay, well, this might be easier to solve than I thought. Return. Boom. There we go. Let's make sure that we got rid of all of the print statements. We did. Crap. Well, obviously that was the wrong way. It seems like that's what we should have done. Cost to not place. Seems like there shouldn't be a cost to not place it. Okay, let's get rid of this here. ABBA. Okay, well, I mean, I feel like I'm 99% of the way there and having a brain fart. So I guess let's look at somebody else's. I don't want Java code. Show me a Python. Okay. I want something that's similar to my approach, but that shows me how it breaks. Greedy. I'm not really recursing. Smallest palindrome. No valid. Okay. Use this as next character. Oh, this is interesting. He's using the fact that it is a palindrome to extract the contents. Go away. Update ways. All right. You know what? I think that this is where I think we're going the wrong direction here. Let's try to figure out How to detect what situation is unique when nothing is being placed. I mean, it really seemed like just returning nothing. If you can't find a letter, then return nothing. Did I, like, put the indent wrong or something? Did I put it here? I don't think I put it there. For K in sorted C dot keys. If oh, for hell's sake. We broke out of this, but we okay. Yeah. Placed equals false. Placed equals true. If not placed. Okay, that was kind of dumb. Okay. I do not want to throw the towel in this late in the game. But I will admit that I'm getting frustrated. It seems like we're there. It seems like we're there already. Child permutations. We need parent permutations, right? Isn't parent permutations just child permutations plus one extra letter? Okay. What is the maximum number of permutations? All right, let's do it. What is just the maximum number of permutations of the string? I hate this. Just the maximum number of permutations of the string. Okay, total permutations, number of characters in a string. This handles duplicates correctly. Okay, for a string. Unique permutation count. Okay, let's just take a look at this. Math factorial. For large string is not feasible to compute directly. You'd want to compute using logarithms. Let me know if you want it capped. Show me a capped value. Maybe in the end I'm just not smart enough to do this problem. It's kind of depressing. All right, capped unique permutation count. I think that I did learn something. I still allowed myself to get a little frustrated along the way. So, no, this is depressing, but whatever. I'm ready to be done with the problem. So, capped unique permutation count. All right, smallest palindrome. So we will say if k is greater than or equal to cap self.cal capped unique permutation count, then return nothing. Otherwise, return the kth permutation plus the outlot plus the reversed. Okay, and then we don't need a placed. Let's do it. Solution object has no values. K equals 2. Print k, comma, was this one based? This wasn't one based, was it? I mean, A, B, and BA, that's 2. I don't think that this is right. Capped unique permutation count. NYG. GYN. This is just straight up the wrong answer. It passed 128 tests before it identified them. All right, let's look at somebody else's solution. Clearly, this is wrong. Permutation, k, let's go. All happy paths. Only need to form the first half. Yes, that is true. For me, the big part was doing avoid computing. This is very similar to our code. You could say, oh, times n26 due to the character array. Space complexity. All right. Smallest palindrome. So he put this all in one. So let's erase what we did here and see if we can figure out this code here. Middle character. You know, this is taking advantage of the fact that it is already a palindrome, which is probably something that I should have done. Okay, so count. I would have used a dictionary, but this is fine. Only need half the counts since we'll form the first half, then the second half is mirrored. Well, yeah, but why count them in the first place? Why not just use a counter? Okay, no, this is fine. This is not my time to scrutinize. Okay. mean, it made sense for me to do this when I was using the counter class. All right, for I in range length vest divided by 2. For j in range length of count. Yeah, I shouldn't be nitpicking when he got the right answer and I didn't. Try the first available character. Count of j minus equals 1. Use this as... We add back if the character is an intro. This is the way ChatGPT did it. I just... It makes much more sense to me to just deduct it when you use it. You know what? Maybe if I had done it this way, I would have been able to detect the failure condition, though. Ah, I didn't think of that. Okay, letters equals sum of count. Oh, right, just the number of letters that we have. That makes sense. It's the same thing I was doing. For frequency in count, frequency is greater than 0. Okay, this looks a lot like the ChatGPT solution. Oh, maybe that's because it's the right solution. If Waze is greater than or equal to k, avoid computing large numbers over k. If Waze is greater than or equal to k. Okay, this is almost identical to what we were doing. Update Waze. For else. I swear to God, that's what I did. I got to the end of trying all of the characters, and if I hadn't used one, then I returned nothing. I swear that's what I did. I don't understand. Okay. I think I was confused on some nuance, but... Well, remember I said, shouldn't we have to deduct the character that we're considering using from the number of combinations? Okay. Even though I didn't technically get the right answer, I do think that I've learned something. And I'm a little burnt out. I think it's time for some exercise.